quadratics over C, which is the complex field. So to factorise a quadratic, we're first going to complete the square. So x squared plus 8x plus 52, I'll write that as x squared plus 8x, and I'll halve the 8, which is 4, and square it to make 16. I'll look at the 52 and say how much more on top of 16 do I have to add to make up to 52, and that's plus another 36. This initial part of the expression then is a perfect square. I'll write that as x plus 4 all squared plus 36. Now what I want to do is express that as a difference of squares. To make it into a difference of squares, I have my x plus 4 all squared. The plus I need to make a minus 36. To make it back to a positive, I need to multiply by negative 1. In our case, negative 1 is equal to I squared. Now it's expressed as a difference of squares. I can go ahead and write it as a factorisation as x plus 4, where that is my a, minus 6i, a minus b, and x plus 4 plus 6i. And that's the quadratic factorised over the complex number field. I'll do one more quick example. In this example, it's not a monic anymore, I have 2. Now before I can complete the square, I need to make it monic. I'll take out the common factor of 2, make it x squared minus 2x plus 3. Then again in here, this expression inside the brackets here, I will complete the square on. So I'll say 2x squared, half of this is negative 1, and squared is 1. So I've got x squared minus 2x plus 1. To make up my 3, I need to add another 2 onto the expression. So I have 2 brackets. This part here is a perfect square. It's x minus 1 all squared. Another bracket in there. This plus I need to make a minus, and I'll keep the 2 there. And again, I need to make it back to positive. I need to multiply by negative 1, or I squared. So continuing the factorisation, I now have it as a difference of squares. I'll write it as 2x minus 1 minus, this is root 2i, and the other term will be x minus 1 plus root 2i.